The requirement for arc fault protection in bedrooms in new construction is independent of the presence of a reliance type transfer switching panel. Arc fault circuit interrupters, also known as AFCIs, are required in all bedrooms in new construction, regardless of occupancy, as per the National Electrical Code, specifically Section 210.12c. These AFCIs are designed to detect and interrupt potentially hazardous electrical arcs that can cause electrical fires. Reliance-type transfer switching panels allow for automatic switching between two sources of power, for example, the primary power source and a backup power source. It is important to note that the use of reliance-type transfer switching panels is not a substitute for arc fault circuit interrupter protection. The reasoning behind this is that electrical fires can occur in bedrooms regardless of whether a reliance-type transfer switching panel is present. Arc fault circuit interrupters provide an additional layer of protection against electrical fires by detecting and interrupting arc faults. The presence of a reliance-type transfer switching panel does not alter the risk of arc faults occurring in bedrooms. Therefore, the requirement for arc fault circuit interrupter protection in bedrooms in new construction remains in effect even if a reliance-type transfer switching panel is installed. Both arc fault circuit interrupters and reliance-type transfer switching panels serve different purposes and provide different levels of protection for electrical systems. Let's delve further into the specific requirements and functionalities of arc fault circuit interrupters and transfer switches. Firstly, arc fault circuit interrupters are designed to mitigate the risk of electrical fires caused by arcing faults. These faults can occur due to damaged or deteriorated wiring, loose connections, or other issues that create unintended electrical discharge. An arc fault circuit interrupter continuously monitors the electrical circuit for specific signatures that indicate the presence of an arcing fault. These signatures include erratic current flow, high-frequency noise, and other anomalies that are characteristic of arcing events. When an arc fault circuit interrupter detects an arcing fault, it quickly interrupts the circuit, cutting off the flow of electricity and preventing the arc from escalating into a fire. Secondly, there are different types of arc fault circuit interrupters, including branch/feeder AFCIs and combination AFCIs. Branch/feeder AFCIs provide protection for the entire branch circuit, while combination AFCIs offer enhanced protection by detecting both series and parallel arcs. Series arcs occur when there is a break in a single conductor, while parallel arcs occur between two conductors. Combination AFCIs are generally required for new installations in bedrooms and other designated areas to provide comprehensive protection against both types of arcing faults. Thirdly, the National Electrical Code, or NEC, provides detailed requirements for the installation and use of arc fault circuit interrupters. Section 210.12 of the NEC specifies the locations where AFCI protection is required, including bedrooms, family rooms, living rooms, parlors, libraries, dens, recreation rooms, sunrooms, closets, hallways, and similar areas. The NEC also provides guidance on the selection and installation of arc fault circuit interrupters to ensure proper operation and effectiveness. Let's examine transfer switches and their role in electrical systems. A transfer switch is a device that allows for the transfer of electrical power from one source to another. This is commonly used in backup power systems where a generator or other alternative power source is available to provide electricity during a power outage. The transfer switch ensures a seamless transition between the primary power source and the backup power source, minimizing disruption to critical loads. There are two main types of transfer switches: automatic transfer switches and manual transfer switches. Automatic transfer switches automatically detect a power outage and switch to the backup power source without any manual intervention. Manual transfer switches require manual operation to switch between power sources. Reliance-type transfer switching panels are a specific type of transfer switch that is commonly used in residential applications. These panels typically include a manual transfer switch and a load center, allowing homeowners to easily switch between utility power and generator power during an outage. Now let's consider the interaction between arc fault circuit interrupters and transfer switches. It is important to understand that the presence of a transfer switch does not eliminate the need for arc fault circuit interrupter protection in bedrooms or other areas where it is required by the NEC. Arc fault circuit interrupters protect against arcing faults that can occur regardless of the power source, while transfer switches provide a means of switching between power sources. In other words, arc fault circuit interrupters address a specific type of electrical hazard, while transfer switches address power supply continuity. Therefore, both arc fault circuit interrupters and transfer switches are necessary components of a comprehensive electrical safety system. It is also important to ensure that the arc fault circuit interrupters are properly coordinated with the transfer switch to prevent nuisance tripping or other issues. Coordination involves selecting arc fault circuit interrupters with appropriate trip characteristics and ensuring that the transfer switch does not create any conditions that could cause the arc fault circuit interrupters to operate unnecessarily. Furthermore, it is essential to follow all applicable codes and standards when installing arc fault circuit interrupters and transfer switches. The NEC provides detailed requirements for the installation, wiring, and protection of these devices to ensure safe and reliable operation. In summary, arc fault protection is required in bedrooms in new construction, irrespective of the presence of a reliance type transfer switching panel. Arc fault circuit interrupters and transfer switches serve different purposes and provide different levels of protection for electrical systems. Arc fault circuit interrupters protect against arcing faults, while transfer switches provide a means of switching between power sources. Both devices are necessary for a comprehensive electrical safety system, and it is important to ensure that they are properly coordinated and installed in accordance with applicable codes and standards. To further clarify the requirements for arc fault circuit interrupter protection, let's examine specific sections of the National Electrical Code, or NEC, that address this topic. As previously mentioned, Section 210.12 of the NEC covers arc fault circuit interrupter protection requirements for dwelling units. This section specifies the locations where arc fault circuit interrupter protection is required, including bedrooms, family rooms, living rooms, parlors, libraries, dens, recreation rooms, sunrooms, closets, hallways, and similar areas. The NEC also defines the types of arc fault circuit interrupters that are acceptable for use in these locations. In general, combination arc fault circuit interrupters are required for new installations to provide comprehensive protection against both series and parallel arcs. The NEC also allows for the use of other types of arc fault circuit interrupters in certain situations, such as replacement installations or where existing wiring does not permit the installation of combination arc fault circuit interrupters. It is important to consult the NEC for specific requirements and exceptions related to arc fault circuit interrupter protection. In addition to Section 210.12, other sections of the NEC may also be relevant to arc fault circuit interrupter installations. For example, Section 110.3 provides general requirements for the examination, installation, and use of electrical equipment, including arc fault circuit interrupters. This section emphasizes the importance of following manufacturer's instructions and ensuring that equipment is installed in a neat and workmanlike manner. Section 406.4d4 addresses the replacement of receptacles in locations where arc fault circuit interrupter protection is required. This section specifies that when replacing receptacles in these locations, the replacement receptacle must be arc fault circuit interrupter protected. This requirement helps to ensure that existing homes are brought up to current safety standards over time. Let's consider some practical examples of how arc fault circuit interrupters and transfer switches are used in residential electrical systems. In a typical home, arc fault circuit interrupters are installed in the electrical panel to protect the branch circuits that serve bedrooms and other designated areas. These arc fault circuit interrupters continuously monitor the electrical current for signs of arcing faults. If an arcing fault is detected, the arc fault circuit interrupter will trip, interrupting the circuit and preventing a potential fire. In the same home, a transfer switch may be installed to allow for the connection of a portable generator during a power outage. The transfer switch allows the homeowner to safely switch between utility power and generator power, ensuring that essential appliances and devices can continue to operate during the outage. When the power goes out, the homeowner can start the generator and use the transfer switch to switch the electrical system over to generator power. The arc fault circuit interrupters will continue to provide protection against arcing faults regardless of whether the power is coming from the utility or the generator. It is important to note that the transfer switch must be properly installed and wired to prevent backfeeding, which is a dangerous condition where electricity from the generator flows back into the utility grid. Backfeeding can create a safety hazard for utility workers and can also damage electrical equipment. To prevent backfeeding, transfer switches are designed to isolate the home's electrical system from the utility grid when the generator is in use. In addition to residential applications, arc fault circuit interrupters and transfer switches are also used in commercial and industrial settings. In these settings, arc fault circuit interrupters provide protection against electrical fires in offices, factories, and other commercial buildings. Transfer switches are used to provide backup power for critical equipment and systems such as emergency lighting, fire alarms, and data centers. The requirements for arc fault circuit interrupter protection and transfer switch installations in commercial and industrial settings are similar to those in residential settings, but there may be additional requirements depending on the specific application. For example, the NEC may require the use of specific types of arc fault circuit interrupters or transfer switches in certain hazardous locations. It is important to consult the NEC and other applicable codes and standards to ensure that arc fault circuit interrupters and transfer switches are properly installed and used in commercial and industrial settings. Now let's explore some common misconceptions about arc fault circuit interrupters and transfer switches. One common misconception is that arc fault circuit interrupters are a substitute for ground fault circuit interrupters, or GFCIs. While both arc fault circuit interrupters and ground fault circuit interrupters provide protection against electrical hazards, they protect against different types of hazards. Arc fault circuit interrupters protect against arcing faults, which can cause electrical fires, while ground fault circuit interrupters protect against ground faults, which can cause electrical shock. Ground fault circuit interrupters are typically required in wet locations such as bathrooms and kitchens to protect against the risk of electric shock. Arc fault circuit interrupters are typically required in bedrooms and other designated areas to protect against the risk of electrical fires. Another common misconception is that transfer switches eliminate the need for surge protection. Surge protection devices, or SPDs, protect against voltage surges which can damage sensitive electronic equipment. Transfer switches provide a means of switching between power sources, but they do not protect against voltage surges. Therefore, surge protection devices are still necessary to protect electronic equipment, even when a transfer switch is installed. It is also important to understand that arc fault circuit interrupters can sometimes nuisance trip, meaning that they trip even when there is no actual arcing fault. Nuisance tripping can be caused by a variety of factors, such as faulty wiring, electrical noise, or certain types of appliances. If an arc fault circuit interrupter is nuisance tripping, it is important to investigate the cause of the tripping and take steps to correct the problem. In some cases, it may be necessary to replace the arc fault circuit interrupter with a different type or model that is less prone to nuisance tripping. Another consideration is the coordination of arc fault circuit interrupters with other protective devices in the electrical system, such as circuit breakers and fuses. Coordination involves selecting protective devices with appropriate trip characteristics to ensure that they work together to protect the electrical system from overloads and short circuits. Improper coordination can lead to nuisance tripping or, in more serious cases, failure of the protective devices to operate properly. Therefore, it is important to consult with a qualified electrician to ensure that all protective devices in the electrical system are properly coordinated. In addition to the technical aspects of arc fault circuit interrupters and transfer switches, it is also important to consider the legal and regulatory requirements related to these devices. As previously mentioned, the National Electrical Code, or NEC, provides detailed requirements for the installation and use of arc fault circuit interrupters and transfer switches. The NEC is a widely adopted code that sets the standard for electrical safety in the United States. Many states and local jurisdictions have adopted the NEC into law, making it a legal requirement to comply with the NEC standards. In addition to the NEC, other codes and standards may also be relevant to arc fault circuit interrupter and transfer switch installations. For example, the National Fire Protection Association, or NFPA, publishes standards related to fire safety, including standards for electrical systems. It is important to consult with local building officials and electrical inspectors to determine the specific codes and standards that apply to arc fault circuit interrupter and transfer switch installations in a particular area. Failure to comply with applicable codes and standards can result in fines, penalties, and other legal consequences. It can also create a safety hazard for occupants of the building. Therefore, it is essential to ensure that all arc fault circuit interrupter and transfer switch installations are performed in accordance with applicable codes and standards. To summarize, the requirement for arc fault circuit interrupter protection in bedrooms in new construction is independent of the presence of a reliance type transfer switching panel. Arc fault circuit interrupters and transfer switches serve different purposes and provide different levels of protection for electrical systems. Arc fault circuit interrupters protect against arcing faults, while transfer switches provide a means of switching between power sources. Both devices are necessary for a comprehensive electrical safety system, and it is important to ensure that they are properly coordinated and installed in accordance with applicable codes and standards. It is also important to address common misconceptions about arc fault circuit interrupters and transfer switches and to understand the legal and regulatory requirements related to these devices. By following these guidelines, you can help to ensure the safety and reliability of electrical systems in residential, commercial, and industrial settings. To elaborate further on the coordination between arc fault circuit interrupters, or AFCIs, and other protective devices, such as circuit breakers, let's consider a scenario where an overload occurs on a branch circuit protected by an AFCI. If the overload is severe enough, it could potentially damage the wiring or equipment connected to the circuit. In this scenario, it is important that the circuit breaker protecting the branch circuit trips before the AFCI trips. The circuit breaker is designed to protect against overloads and short circuits, while the AFCI is designed to protect against arcing faults. If the AFCI trips before the circuit breaker, it could potentially leave the circuit unprotected from the overload, which could lead to damage or even a fire. To ensure proper coordination, the circuit breaker must have a lower trip threshold than the AFCI. This means that the circuit breaker will trip at a lower current level than the AFCI. This will ensure that the circuit breaker trips first in the event of an overload, protecting the circuit from damage. It is also important to consider the time current characteristics of the circuit breaker and the AFCI. The time current characteristic describes how long it takes for a protective device to trip at a given current level. The time current characteristics of the circuit breaker and the AFCI must be coordinated to ensure that the circuit breaker trips before the AFCI in the event of an overload. In addition to coordinating with circuit breakers, AFCIs must also be coordinated with other protective devices, such as ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect against ground faults, which can cause electrical shock. In some cases, both an AFCI and a GFCI may be required on the same branch circuit. In these cases, it is important to ensure that the AFCI and the GFCI are properly coordinated. The AFCI and the GFCI must be selected and installed in such a way that they do not interfere with each other's operation. For example, if the GFCI trips, it should not cause the AFCI to trip, and vice versa. To achieve proper coordination, it is often necessary to use specially designed AFCIs and GFCIs that are compatible with each other. These devices are designed to work together to provide comprehensive protection against both arcing faults and ground faults. Let's now turn our attention to the installation of transfer switches and the considerations that must be taken into account to ensure a safe and reliable installation. One of the most important considerations is the proper sizing of the transfer switch. The transfer switch must be sized to handle the maximum load that will be connected to it. If the transfer switch is undersized, it could overheat and fail, potentially causing a fire or other safety hazard. To determine the proper size of the transfer switch, it is necessary to calculate the total load that will be connected to it. This includes the wattage of all appliances, lights, and other electrical devices that will be powered by the transfer switch. Once the total load is calculated, the transfer switch must be selected to have a capacity that is greater than or equal to the total load. In addition to proper sizing, it is also important to ensure that the transfer switch is properly wired. The wiring must be of the correct gauge and type to handle the current that will flow through it. The wiring must also be properly connected to the transfer switch and to the electrical panel. Improper wiring can lead to overheating, short circuits, and other safety hazards. Another important consideration is the location of the transfer switch. The transfer switch should be located in a dry, well-ventilated area where it is easily accessible. The transfer switch should not be located in a damp or humid area, as this could lead to corrosion and failure. The transfer switch should also be located away from flammable materials, as this could increase the risk of fire. In addition to these general considerations, there are also specific requirements for the installation of transfer switches that are outlined in the National Electrical Code, or NEC. The NEC provides detailed guidance on the wiring, grounding, and protection of transfer switches. It is important to consult the NEC and to follow all applicable requirements when installing a transfer switch. Finally, it is important to have the transfer switch inspected by a qualified electrician after it is installed. The electrician can verify that the transfer switch is properly sized, wired, and installed. The electrician can also perform tests to ensure that the transfer switch is functioning properly and that it is safe to use. By following these guidelines, you can help to ensure that the transfer switch is installed safely and reliably and that it will provide backup power when it is needed.